All right, next is a help request for exercise 8.1, which is generating a PXY phase diagram using Rayold's law. Okay, and so in the example in the chapter, we looked at essentially calculating pressure, vapor composition for a known T and X, which is essentially what you're going to be doing repetitively here. Only here you'll create a vector of X values, loop over those X values, and solve for each case. And then in 8.2, we'll do a TXY, and we considered in the text an example where for a known P and X value, you solved for T and Y, right? And so essentially we're just going to create loops and use the code that was generated in the text or put together in the text for those specific cases to repetitively solve. Okay, but let's see. So the comment that I received was more so that their code wasn't working, that they had an issue with non-square matrix. Okay, and oh no, they're gonna. Okay, so first thing I see is they're gonna make us create a vector of Antoine constants, and that's fine. Okay, it says Ant is a matrix of Antoine constants. Row 1's ABC for hexane, then the two different for cyclohexane. Okay, so the first thing this tells me is I don't want to type that in every time, right, to call. And so I'm going to create a new script that's just my, I don't know, help caller. Okay, and let's see if we can have any luck copying and pasting this. Okay. Not so fortunate. Okay, so let me create this matrix of Antoine constants. Okay. Okay, this is just so I don't have to type this in every time. So let's see. Let's see if it doesn't look like I'm going to be able to do a row. So 7.1. Boy, I'm getting all scrambled up here in terms of tabs. Okay. B, C. Then one nice thing about doing these things in the editor, so semicolon means next line, I could keep going, but I could actually just return to a new line since it's in a script and keep going. Okay. Maybe you'll have better luck copying and pasting than me, but get this all situated. Bam. I can't keep track of my order of my screens. It's because I'm missing my cup of coffee here. Okay, so now I have my Antoine constants, and before I scroll back, we're looking at 343.15 Kelvin. That, bam, bam, and let's just do, so let's just put a little label up here. So this is my matrix of Antoine constants. Okay, so I expect your documentation would be better, but in the interest of time here, let's do temperature and Kelvin. Temperature in Kelvin's 343.15. Okay, so let's do TK. Is 343 343.15 343.15. Okay, got it. Okay, and then our note was our Antoine constants are actually in Kelvin. Okay, and so in C. So let me call this Rayold caller. Okay, my last comment was Antoine constants here, right? They use temperature in degree C, and so we'll make sure you convert in your code. Okay, but then to call this, so it looks like you have Rayold PX, and are you going to tell me the units of temperature? It looks like you're going to make me guess. All right, so let me try and find it so then I can call your code and try and see your error function. Because your error function, or your error, is essentially suggesting you have more equations than unknowns, or vice versa. Okay, it looks like you're taking your t to be in degree c. Okay. So if I want temperature in C, T is T Kelvin minus 273.15. Okay, so all I'm doing is creating some code to call your function, so I don't need to keep typing that matrix of Antoine constants in my command window. Okay, so let's see what happens. So if I create this rail caller and I run it, okay, we get some error messages. Okay, looks like it keeps repeating. Okay, but yeah. So basically, the default method, these dogleg methods used by fsolve, assume you have a square system of equations. So you have as many unknowns as you have equations. If you have more unknowns than equations, or more equations than unknowns, then you're going to use an optimization technique. And so the one that fsolve has that can do this is this Levenberg Marquardt. Okay, so that's a warning message. It's not an error, but we have a system of square equations, which is suggesting to me that you've got things set up not quite right. And so let's take a look and see what we have. Okay, so you read in your matrix of Antoine constants and your temperature. Then you chop off the first row. Okay, so you're going to calculate the vapor pressure of component 1 and component 2. So you take your Antoine constants for component 1 as the first row from that matrix, and then the temperature. Right, so that's where it's the temperature in degree C. Then let me go to Antoine. So you unpack your vector of Antoine constants, and you calculate your vapor pressure. So this is vapor pressure in millimeters of mercury, but then you convert it to pascals. Okay, so let me just make a note for myself. This is vapor pressure in pascals. So then if we compute P is going to be in pascals. I create a vector of x values. Then for each x, I'm going to solve for y and p. So you size y and p. That's good. Then I'm going to loop over my vector of x values. For each x, I'm going to pass to my Rayold's law error function. You're passing x1, vp1, vp2, and y. Okay, y is your unknown, so we'll look in your error function, so you should unpack that. What I'm trying to solve for in each case for each x is y, 1, and p. Okay, so we'll look at that. And then my other guess in terms of what is going to be wrong is x1 here. Each iteration, so I'm creating a vector of x values. I want to loop over my x values. In each iteration, I want to solve for y and p with that given value of x. Right? It's for that given x and that given t. Where t comes in, though, is t is just psat, right? So for a fixed t, I have a fixed psat for component 1 and component 2, right? If I know t, that's equivalent to knowing the vapor pressure of pure component 1 and pure component 2. All right, so t is constant, so psat 1 and psat 2 are constant. And so then what I'm going to do is I'm going to create a vector of x, loop over that x value. Each iteration, I'll solve for y and p for that given value of x in that iteration, and that given value of t, which corresponds to psat 1 and psat 2. So if I look at your error function, you saw Antoine was fine. Okay, y I unpack, and I get y1 and p, so that's good. Yeah, so my issue here is x1 is your vector of x values that you created up here. Okay, so x is that vector 0 to 1 in increments of 0.02. Okay, so then x2 is also going to be a vector. Okay, and so then what will happen here is vp1 is a constant, so it's a constant times a vector. And so I would guess the issue is going to be this is a scalar minus a vector, which I think should result in a vector. We could test it out in the command window, and then that means res1 and res2 would both be vectors and not scalars, which is what's causing your problem. So if these are vectors, row vectors, you're going to have a ton of unknowns, which is going to be problematic. So what is the fix? I think the fix is just up here. I think you just need to pass the nth element of x1, right? The x1 value for that particular loop iteration. Then here's your initial guess for y1 not and p not, or for y and p. That's fine. You use those as your initial guesses, 2 initial guesses. All right, so 2 initial guesses. That means you're telling fsolve that you should have 2 unknowns, right? Not a ton of them. And then you solve. Okay, so now it says convert the pressure found to, okay, so you're converting pressure from pascals to kilopascals, and that's what you're storing to your vectors. That all looks great. Okay, let's see if that alone solves your problem. Okay, and then if it does solve it, you would of course want to add that reference data, which you're told to compare to in the problem set. Okay, I'm not going to type that up. Okay, so we had rail caller. Okay. So it looks like I'm still getting the same error message. Okay, so let me make this full screen. I'll try and see what we have going on. So P, X, and Y. So okay, so we have the same issue. So let me reduce this. Okay, let me make this big again, and let me make sure I actually have this. Antoine should be right. Oh, okay, so now next issue, right? It's kind of the same thing. So P naught, my initial estimate of P, you're referring to x1 here, which is my vector of x1s. So this would create a vector of, P naught's going to be a vector. So that means you have a vector of initial guesses. And so this means you've got a bunch of initial guesses. So you're telling MATLAB that you should expect a bunch of unknowns. But now that we fixed your error function, you only have 2 equations in your error function. So you have 2 equations with a ton of unknowns, which is again why it's not square. So this should be x1n and x1n. Okay. And let's try again. Okay, beautiful. Okay. So plot, looks like I probably just didn't close your last plot window. So let me close that and rerun it. All right, so you're not, orange doesn't pop up every time I solve. I get what looks like a nice phase envelope. All right, your output's your PXY data as you had it set it up, which is great. You're not seeing orange there. So that fixes the problem. Okay, so the problem was just in your for loop, you were referring to x, which is a vector of x values, where you want to refer to the nth x, right? The x value for that given iteration. Cool. Then the only other thing I would see in terms of wrapping up this problem would be to create, say, a vector for your reference data or a matrix that contains all your reference data and add that to your plot for comparison. Okay, but otherwise, it looks good, right? And so if you're using fsolve and you get this, warning message that your system of equations isn't square, that means you have more unknowns than equations or more equations than unknowns. Okay, one or the other. Okay, and so that would flag me to look at your error function. okay, and see if there's an issue there, where in your case you're passing a vector of x values, which was creating essentially a vector of error functions, even though it didn't look like it. And then you also had x1 in your loop to generate your initial guesses, and so you're giving a vector of initial guesses, larger than 2, which was telling MATLAB that you were trying to solve for more than those 2 unknowns. That wasn't quite right. Okay, but otherwise, looked great. Great setup in terms of reusing the code from the chapter and getting it working here. And great job collecting your data.